Hello and welcome to Spy Math. This is Mr. Spy, and this will be part 4 of the June 2018 Geometry Regents, the proof question. Let's begin. Given parallelogram ABCD with segment BF perpendicular to AFD, mark off both right angles just in case, and segment DE perpendicular to BEC, mark off the other right angle here. These tick marks that I make with the right angles are extremely important. Now let's mark off parallelogram ABCD. So this line AB is parallel to CD, and AD is parallel to BC. They're also congruent. So AB is congruent to CD. BC is congruent to AD. That's everything you can mark off just by looking at the givens. And we want to prove that BEDF, this inside, it's a rectangle. Now there's many ways to do this proof. You could do it without even looking at the triangles that are given. There's a short version of this proof, there's a long version of this proof. I have typed up one version of this proof. This is one answer. If you're interested in more answers, you could put a comment below and I'll give different versions of the answer. But this to me is the shortest and most concise answer. It may have more steps than is required for the Regents, but for me this is the proof I did and the proof I prefer. So let's look at my already typed up proof and let's begin. So here it is. Our plan, my plan, is to use the properties of parallelogram and the fact that a parallelogram with one right angle is a rectangle to show the quadrilateral BEDF is a rectangle based on the given information. So that's my plan. First, we're given the parallelogram ABCD is given, and we're going to use the fact that opposite sides are parallel, specifically BC is parallel to AD. If a quadrilateral is a parallelogram and opposite sides are parallel, then we're going to break up those two sides into its parts. BE plus EC equals BC, and DF plus FA equals DA, the whole equal to sum of its parts. It's an extra step to show the parts of the parallel sides as parallel. This is actually not a needed step, but it's a good step to show you know the parts, because we're about to show something that parts of segments are parallel. By stating that we know the parts, BE is part of BC, and FD, hold on a second. See, I even made a mistake without showing the parts. So, FD is part of AD. So, since parts of parallel segments are parallel, so BE is parallel to FD. So, two segments are parallel, and all parts of those segments are parallel. Then we'll use the second given, which is the perpendicular sides. BF is perpendicular to AFD, and D is perpendicular to BEC. That means BFD, angle BFD is a right angle. Perpendicular segments form right angles. Two segments or lines are perpendicular, then the segments make the right angles. Then we also know that BF is parallel to DE if two lines or segments are perpendicular to two parallel lines. Perpendicular lines or segments are also parallel. This is a very rarely used reason, but since it's a proof that uses this reason, I wanted to emphasize it. It's a beautiful reason to use. In most cases, we'll never use a reason like this. We usually try to work with the other two right triangles or the triangle proof. You can see that. Put a comment below. Question step 7. Quadrilateral BEDF, just in the middle. BEDF is a parallelogram because if both pairs of opposite sides of quadrilateral are parallel to each other, then the quadrilateral has a parallelogram. We just prove that those two sides are parallel and that these two sides are parallel, and we're using the fact that right here it's a right angle. So we have a parallelogram with one right angle. This is an extremely important reason. Quadrilateral BEDF is a rectangle, which is our final step with the therefore symbol. The parallelogram has one right angle, and then the parallelogram is a rectangle. Q, E, D. A little box at the end, the F symbol, not really often used in this class. The symbol, just to remind you, means there. 4. And this symbol means QED. It's a way of finishing a proof. It's a fancy Latin term. That's it to this proof. If you really like this method doing a proof and you want to go through the properties of quadrilateral, post the video below. I will be having a video coming up later this year on the properties of quadrilateral and using all these unique statements that do not appear in a proof often, and also have many triangle proofs coming up over the school year. This is Mr. Spy, signing off.